So we've seen that we can call functions that are written by somebody else, either from a friend or an instructor who's provided us with the details of that function in a file, or from somebody who's written and contributed to one of the libraries that's associated with Python. But you don't always want to be mooching off your friends. Sometimes you'll have great ideas and you'll want to implement those in functions too. So we'll be learning about how you can write your own function in Python. First, let's look at an overview of a Python file. So far this semester, we've been including some comments at the top of our file to specify the purpose of the program, to include information like our name or contact information about us, and maybe some details about the name of our file. We'll still include those header comments at the very top of our Python files. The next thing that you should include in your Python files is the import statement for any non-standard libraries or local library files that you're going to use in your code. The third thing that goes in your file is the actual code for any functions that you implement. This is different than function calls. This is where you might write your own function that you can call from within your main Python program code. And then finally, the fourth thing that you'll include in any Python file is your main executable code that carries out the algorithm for your project and maybe calls some of the functions either from the standard library, the non-standard library, local library files, or code that you've written yourself and placed in a function at the top of your program. Let's write an example program that includes all of these components where we write a special function that calculates the average speed that somebody's traveling. And then we'll use our custom function from our main code in our program. Let's first look at the syntax for writing the function. In Python, a function always starts with the reserved word def. It's short for define. So we're saying, I want to define my own function, and then the next thing we provide is the name that we want to associate it with the function. Whatever identifier we want to choose that people will type into their program where they want to call our function into action. Then we're going to include a number of items in parentheses here. We're going to call them parameters. And parameters are the placeholder names that we're going to use inside our function's algorithm, inside all of the statements inside our function body that refer to these pieces of information that are passed in from outside the function. We call those parameters. After the parameter list, we'll have a colon. And we know in Python, the colon always means we're going to include a chunk of statements. We're telling Python this group of statements all go together and are part of this named function that I'm creating. Inside the function body, the part that's indented, we're going to place all of our executable statements to carry out our function process. If the function returns a value, the last line in our function should be return and then the name of the variable that we'd like to return. If the function doesn't return a value, then the last line in the function should simply be return, which means this function is going to end now. Let's talk a little bit more about parameters. Let's think back to our black box picture. We know that when we're calling a function, we view the function as the name of the function, and we know that it has some internal workings, some individual Python instructions that carry out an algorithm in here. And we pass in arguments from the outside. That's the information that we provide. Now, when the function itself pulls in information as an argument, it doesn't know what variable names or literal values might be associated with those arguments. It needs to use a placeholder name to keep track of the first bit of data, the second bit of data, and so on that are passed into the function itself. We call those names that we give to the individual placeholder values parameters. So when we're writing our function, we want to make it work with different values, and we can't predict what values the user might pass into our function. So we're going to create an identifier that represents each piece of information that comes in from outside, and then we'll build our algorithm using those identifiers rather than focusing on specific values that might be passed in by the person calling our function. Now, sometimes when you're writing a function, it's important to do a little bit of planning, just like we plan before we write a piece of software. Whenever we're defining our function, we want to think about what kind of information is required for input, what processing steps will the function accomplish, and what's the response from the function at the end. So it's sort of like an IPO chart where we think about what's the input to our program, what's the user going to enter, what processing steps are going to be required, and what output is going to be communicated back to the user. Thinking about the same kind of information, but in that black box scenario. We want to know what information needs to come into the box, what's required to make the function work. We need to know what processing steps the box itself will take, what the algorithm steps are. And finally, we need to know what kind of response we'll be returning back from the black box. When we're writing functions, instead of calling the information that comes in from outside the input, we're going to call it the arguments and parameters. You know, the arguments are the actual values that are passed in when we call the function. The parameters are the placeholder names that we'll use when we write the function implementation. But those two pieces of information are tied together and get connected whenever we run our Python program. So instead of calling our first column in our planning chart the input column, we're going to call it arguments/parameters. Our center column represents the algorithm that we want to carry out. So we're still going to call that the processing step. And then finally, instead of calling the rightmost column output like we did in the IPO chart, we're going to call it the return value. In other words, the information that's being communicated back from our function. If your function happens to require some input or output inside the function itself, like you're going to put in actual input statements or print statements, you can include those in the processing step rather than in the traditional input or output column in the chart, since we're using those for arguments and return values specifically. So let's think about how to create an APR chart for arguments and parameters, processing, and return value for the average speed function that we want to create. If we know how far we want to travel and the amount of time we've traveled, we can calculate the average speed that we've traveled using this formula. The speed that we're traveling is the distance we've traveled divided by the amount of time required for travel. So let's fill in our various components in our chart. Again, this first column, that's the arguments/parameters. The second column is the processing, and the third value is the return value. The arguments and parameters, that describes the information that needs to be passed in from the outside of this function. Processing is the steps that we're going to have to carry out for this particular function, and the return value is the information that we'll pass back. Let's read our function description again. It says, we know how far we want to travel and the amount of time we've traveled. So in other words, that's the information that's provided. That's the details that are going to be used in our formula. Both of those bits of data come from outside the function. Those are both arguments. So we're going to have the user enter both the time for travel and the distance traveled. Then in our processing step, we want to use our formula to make our calculation for the speed. Speed is the distance divided by the time. And finally, we wanted to return information back to the user. We want to return the calculated speed. That's the information that we're going to return back to the part of the code that calls our function. So looking at this APR chart, we can tell that the function that we're going to write is going to require two arguments, two parameters. And that's because we have two different pieces of information in the A column. And it is going to have a return value because we've specified something in the return value column, the calculated speed. So now we're ready to write the actual code for our function. We can use that generic template for making a function we saw earlier, where we use the reserved word def, provide a name for the function, then we're going to list parameters in parentheses and a colon. Then we'll have all of our executable statements needed to carry out the algorithm for that function. And then finally have either a return with a variable name or a plain regular return at the last line of the function. So let's put that together for our average speed function. We're going to say def, and then pick a name for our function. I'm going to call it calculate average speed. You can call it whatever you want. As long as it's descriptive and describes the purpose of this function, that will be great. Then we said we want to use two different parameters. One's going to represent the time used for travel, and the other one's going to represent the distance traveled. I'm going to call them time for travel and distance traveled. Again, you can call them something else if you'd like to, just make sure it's a descriptive name. And then we end our definition statement with a colon to indicate all of the indented statements that come in below this are going to be part of this particular function body. Next, I'm going to list all my different processing steps. This program just has one processing step where we calculate the speed by taking the distance traveled, the name of my distance variable, and dividing it by the time for travel, my time variable. And then finally, I want to return the calculated speed. So I am returning a value. I'm going to type in the reserved word return and then the name of the variable whose value I want to return back from this function. And that's the speed that I've calculated. I'm going to end it with return speed. And that's me creating my own function. Note, does this code do anything on its own? Think about this. If there's a function in the standard library, does it just magically make your code automatically execute it every time you write a Python program? Or do you have to do something to activate the function? You have to do something to activate the function, right? You have to call it. So let's write our function definition in Python just to test out our theory. So I'm going to make a new Python file. All right, so remember at the top of the program, you put any header information, and then next you include any non-standard or local library functions. We're not gonna need any in this program, so there isn't anything to fill in there. And then the next component that goes into our Python files is the definitions for any of our personal functions that we're writing. So that's where we put our calculate average speed function. And now let's try running our Python program. When we run our Python program, it just returns the prompt. And that means that the program executed, but there wasn't any output and nothing happened. And that's because we didn't have any executable statements in this file. We defined our function, which creates the potential to calculate the average speed. But because we didn't actually call this function on any specific values, it didn't launch this group of code statement into action.